quotient rule. So if your teacher hasn't talked about this concept yet, they probably are going to be about to at some point. And the quotient rule seeks to answer the question of if we have some h of x, which can be represented as some f of x over g of x, then how can we actually figure out what d dx of h of x is in a convenient way for us? Because notice we can't take the traditional sum rule or the product rule or power rule or any of these things. This isn't going to work for us here. So once again, we need to come up with something else for when we have a situation like this. So let's go ahead and define a y that we're going to use. And let's say that that's our h of x, and once again let's do u over v with the uv notation, which is u of x divided by v of x, and let's say we have y equals u over v. Well, let's go ahead and add in our infinitesimal change pieces and see what we get. So y plus delta y equals u plus delta u over v plus delta v. And let's go ahead and isolate the delta y now, so we can eventually get it in delta y over delta x. So to do that, we need to subtract a y from the left and right. So we're going to say delta y equals u plus delta u over v plus delta v, and notice how y equals u minus v, so we're going to subtract u minus v. But now we have a problem that the denominator, both denominators don't match, so we're going to have to go ahead and multiply both of them by 1, and we're going to do it strategically so that both of the denominators will match. So first one, we're going to multiply by v over v, because that's something we're allowed to do. The next one, we're multiplying by v plus delta v over v plus delta v. So now we're going to go ahead and multiply this out. So delta y equals u times v plus v times delta u minus u v minus u delta v divided by v times v plus delta v. So now we have a uv minus uv, so that cancels out. So now we're going to take, we're going to be left with delta y equals v delta u minus u delta v over v is v plus delta v. But now, once again, notice that we have to get this into limit as delta x approaches 0, delta y over delta x form to get our differentials. So this is how we get dy dx. So knowing that, we have to divide by delta x. So let's go ahead and take delta y over delta x, and we only divide the numerator pieces, because if we divided the denominator as well, then it would be like multiplying by 1 and wouldn't do anything. So let's go ahead and do this. So we have v, this is going to become v times delta u over delta x minus u over delta, or we're subtracting u times delta v over delta x minus v, or over v times v v plus delta v. So now what we're going to have to do is get it in this form. So we're going to go ahead and add this part in. So we have limit of delta x approaches 0 of delta y over delta x equals v times limit as delta x approaches 0 of delta u over delta x minus u times the limit of delta x approaches 0 of delta v over delta x over v times v plus delta v. But notice how when we're evaluating this as delta x approaches 0, then delta v also approaches 0, so that's just going to go become v plus 0, or that's going to be a v squared down there. So let's go ahead and evaluate this. So we're going to be left with delta y over, or evaluating, we get dy dx equals, we're going to have v du dx minus u dv dx over v squared, or you could also put back in here that u equals, or that y equals u over v. So we're going to have d u over v dx equals v du dx minus u dv dx over v squared. This is how you're going to see it in a lot of your textbooks as the quotient rule. So this is saying the derivative of some f of x that you can express in some u of x divided by v of x with respect to x equals v of x times the derivative of u of x with respect to x minus u of x times the derivative of v of x with respect to x divided by v of x squared. So yeah, you're going to be using this a lot on your tests and homework. So hopefully you found this helpful, and come back for the next one where Joe shows you how.